Hello, everyone. Thank you for joining us for another VES-Artex Academy webinar. Today, we're talking with Dr. Trevor DeVries, and we're talking about the challenges and opportunities in precision feeding of dairy cows. I'll turn the floor over in a moment, but just before I do, I'd like to mention that we have question and answers at the end of the presentation, and you can ask your questions throughout the presentation using the question and answer feature at the bottom of your screen or through the chat itself. So thank you, Dr. DeVries, for coming and joining us. I look forward to your presentation.
Great, thank you very much. Can you hear me well?
Yes, we can.
Excellent. Well, thank you once again for the opportunity to be part of your webinar series and to be presenting on this topic area here today. If I could get my slides to go forward, that'd be great. Yeah, so today we're going to be talking about challenges and opportunities in precision feeding of dairy cows. And what I'd really like to do is, walk through some of the data that we have to suggest that we have some opportunities here, both at herd level as well as a cow level, but also talk about some of the limitations that there might be in terms of making that a reality on our dairy farms today. There's a lot of discussion in and around the word precision in the dairy industry today, and we hear the kind of the buzz phrase of precision dairy management a lot. This is just one definition of that. So automation using sensor-based management tools that define animal needs and robotic equipment that automatically delivers individual animal management applications. And that's quite a mouthful, and there's quite a bit in there. And so you can get a sense just even from that definition that there's a lot of different kind of opportunities for the application of precision within the dairy industry. And a lot of that is being led or allowed for by the fact that we have a lot of automation and robotics currently being developed and adopted within the dairy industry. And so we see a lot of automation and largely for management tasks on farm. And probably one of the first ones that comes to a lot of people's minds is, say, the automation of milking. We're seeing a lot of growth in robotic or automated milking, but then there's other barn management things that we can talk about, cleaning, reproduction, environment, air quality, health management from, say, a sensor and cow behavior monitoring standpoint. And then finally, which is the point of today's presentation, is the fact that we also have some automation available related to feeding. And there's technology that allows for the development of automation on that front. And so that's really kind of what I'd like to go through in today's webinar, is to discuss how automation can play a role in terms of precision feeding of dairy cattle. And specifically, the two things that I want to walk through, as I mentioned off the top of the presentation here, were the fact that at a herd level, we can do that, and we potentially have some use of automation to improve both the accuracy and precision of the diets we feed. And so we talk about precision, but we also need to talk about accuracy, because that's a big part of that. And then at a cow level, we can also talk about those two things, and specifically whether or not we can accurately meet the nutritional needs of, say, individual cows throughout their lactation, as well as maintain precision in such individualized feeding approaches. And so what I'd like to do is walk through those two areas and specifically give you some examples of why these are important, but then, like I said before, also what are some of the challenges that we have associated with these things. So the first thing, looking at a herd level, we need to think about accuracy of diets before we can actually get into discussion of precision. And what we mean by accuracy is whether or not, basically, as the picture shows us, are we hitting the target when it comes to the diets that we provide to dairy cows? And specifically, we can think of that from the perspective of, we've got a diet that's formulated for the needs of the cow. And the question is, does the diet then that actually ends up in front of those cows accurately reflects that formulation? And again, when I ask that question to many people, does basically the diet that gets delivered to cows match that which is on paper? There's not always a lot of confidence in the response of people to that question. And that can be a little bit troubling for us. But the reality is we know that is likely the case on a lot of dairy operations. And this is just an example of some data that we collected quite a few years ago already. But I like going back to this because it's quite telling in the fact that we do see that variation in relation to, or as opposed to, the target, so to speak. And so what this study did, or what we did in this study, was actually do a cross-sectional study of a cohort of freestall parlor milking dairy herds in Canada that were feeding a TMR. And what we did was we sampled the TMR on those herds for 7 consecutive days, both in the summer and winter time, and then compared the results of the analyses of those samples to the formulated diets that we got from the nutritionists on those farms. And what we found, and not too surprisingly, is that we found that the average TMR that was fed or delivered on those farms varied from the formulation. It exceeded TMR formulation for a variety of nutrients, and it underfed TMR formulation for a variety of nutrients. And some of these, and these are the mean variations, positive or negative, and they don't seem very big, but if you were to look at the actual paper, you'd see that there's tons of variability around here. For example, crude protein, some on average 0.4 percentage points lower than the formulation. However, some farms that was a couple points under, and other farms that was a couple points over. And where this is concerning is the fact that we know that we typically overformulate anyways when we're feeding at a group level. And so that's not necessarily bad, as long as it's not too excessive. But if we're shortchanging cows, say we're underfeeding relative to formulation, it's not then surprising that we might not be, say, we're not only missing that target from a diet standpoint, but we're going to be missing the target from the production standpoint on those animals as well. One of the questions then is, well, what might be contributing to that variability? And there's, or basically missing that target, so to speak. And there's going to be a lot of different things. We couldn't necessarily pinpoint those in that study, but if we think about it, there are a number of bottlenecks which may present themselves and prevent us from being accurate in terms of the diets that we're putting in front of our cows. And so my short answer is, or my short list of kind of questions that we need to think about in terms of making sure that the feed delivered matches that which is formulated on these farms, is asking some questions. Simple things like, how often is feed dry matter checked, right? Is that done daily? Is that done once a week? Is that done once a month? Or is it based on a sample that gets taken when that crop is getting taken off the field and put in the bunker? And obviously, the less often that's happening and the longer that time lag is between that and when we're feeding, obviously the more risk of that variability occurring, because we know obviously that dry matters are not consistent. Forage dry matters, in particular in bunker silos, are going to vary. They're going to vary with weather and even season. And so we need to do a good job making sure that we're checking and adjusting rations and deliveries based on that. Same thing goes for those feed components just themselves. Are we analyzing feed regularly, or are we only analyzing feed a couple times a year? And we know again that the digestibility of forages and particular components of those those forages are going to change across the year. And so we need to be continually updating our rations based on updated feed component analyses. And then from a day-to-day standpoint, do we have mixing protocols in place? Do we know that everybody's actually doing the job that they're supposed to be doing to hit that target, so to speak? And then can we actually follow that up and be able to track what is actually mixed and put in front of cows, so we can see whether or not we are actually being accurate on our farms? And again, this is a good checklist for anybody to go through and think about. But coming back to the topic of today's presentation, and thinking about how we marry accuracy and precision with technology, this represents some opportunities that we have. And we do have technologies that are available to us to improve our accuracy in some of these things. And And so again, just a couple of examples, but right, using say NIR technology to check for nutrient content for dry matter, whether that's handheld, whether that's machine mounted type technologies, and then having say even just simply TMR management software that we can track mixes and deliveries and actually ensure that we're doing the job that we're supposed to be doing. And again, none of these are necessarily that new anymore. And we see a lot of adoption of these technologies already on farm, but these are just a piece of that puzzle, so to speak, in terms of allowing for us to make sure that we're trying to be as accurate as possible with the diets that say we're mixing and putting in front of cows. Now, related to that topic area is then the actual precision of those diets. And so accuracy is hitting the target, and precision is really the consistency in how we're hitting that target. And so we can think about precision as being actually hitting that target consistently in the same spot every day. And so that's another question that we actually have looked at and asked of some of the data that we've had collected in the past is, does that matter? And in the study that I described before, one of the things that we did was actually then look at, because we sampled farms for 7 consecutive days in 2 different seasons, we could look at the day-to-day variation in terms of the nutrient content of those diets that we put in front of those cows. And what we observed was that there was quite a bit of variation between farms in terms of how much day-to-day variability there was. And then that variability actually correlated with intake and production on those herds. And so this is an example of the data that came from that study, whereby in this graph, each of these points represents 1 farm week of data. So basically the measure of, in this case, dry matter intake on those farms at a herd level, average dry matter intake per cow per day, regressed against here on the x-axis, the CV of NEL. And what this stands for is the coefficient of variation of the net energy of lactation of the diet across 7 days. And so it's basically a measure of how much the energy content of the TMR fed on those farms varied from day to day. And so basically a higher number would mean more day-to-day variation in that energy content on those TMR. And what you can see here is a negative relationship, where basically as the variation day-to-day increases, we see less dry matter intake average at a herd level. And again, not a perfect relationship, but strong enough nonetheless. And even if we ignore, say, these outliers here, what we see is about a 1.5 point spread in terms of that variation. Doesn't sound like a whole lot, but according to our statistical model, what this predicted was that every 0.5 point increase was associated with about 1 kilo less dry matter intake per cow per day. And so that 1.5 multiplies out to be about 3 kilograms, or just over 7 pounds difference in dry matter intake at a herd level. And so that's a significant amount of variation in intake that we're predicting from this data set here. That then also translated into a difference of milk yield, and we see that here as well, where again, we see a negative relationship where those farms with more day-to-day variation in their diets are seeing lesser milk yield. Again, quite a bit of variability around that line, but the line equation would tell us that every 0.5 point increase was associated with 3.2 kilos less milk. And so again, looking at all these herds, ignoring those 2 outlier herds, that's close to about 10 kilos or over 20-pound difference in milk yield that we're able to predict just based on that day-to-day variability. And then putting those 2 things together, we also actually, even though those 2 should kind of balance out, what we see is we still see actually an effect in terms of milk production efficiency, whereby those herds, again, that have more variability day to day tend to have lesser feed efficiency than those herds that, say, are more consistent day to day in terms of the diet going in front of those cows. The question is then, well, what's driving this, right? Is it truly day-to-day variation in the diet of those cows? It could be. Some of the studies that have been done since then trying to manipulate this from a cow level kind of experimental standpoint haven't been able to necessarily replicate that. And so it's possible that there's other sources of variability maybe on these farms that are also contributing to these differences that we're seeing. Probably at the end of the day, is probably symptomatic of that variation, and it probably doesn't matter, other than the fact that one of the things that we know is that cows do love consistency. And we see that in a variety of circumstances when it comes to dairy cow management. Many of you will recognize that consistency is king when it comes to milking procedures. If we can keep our milking procedures consistent, we're going to see better outcomes from, say, a teat health, from an udder health perspective at the end of the day. And same thing goes for handling cows, the behavior of cows, and then also from a nutritional management standpoint. If we can keep things consistent, we keep the rumen consistent, we're going to see benefits associated with that. And so one of our challenges then from a feeding management standpoint is to make sure that feed gets mixed and delivered the same way each day. And so not only do we have that accuracy in place where we're tracking things, we're making sure that protocols are being followed, but we do that day in, day out the same. And this is where a challenge really presents itself for the dairy industry, because a lot of these tasks, as you can see in this picture here, we're doing this with machinery, but this is human operated machinery where humans, even though they might be tracking what they're doing, are still going to be prone to mistakes and to variance in terms of what they're doing day in and day out. And so while this can work very well and does work very well, and some people can manage protocols very well and consistency among their labor very well, there is always that element of human error and inconsistency in a lot of these processes. And I think this is where we potentially have some room for basically improvement in precision moving forward into the future, with the opportunity to think about ways of incorporating automation into our feeding processes. And again, we do have systems out there currently that can do that from an automated standpoint. And so there are on the market and currently being used on dairy farms worldwide, systems that can not only mix feed automatically, but also deliver that feed automatically as well. And what that automation does in theory is, again, remove that human variation from the equation and in theory promote greater consistency. Now, again, does that work that way all the time? Well, it requires consistency in terms of ingredients and all those kind of things as well. And so all those things have to be managed well at the same time. But theoretically, these types of systems should provide that precision and consistency. Probably one of the biggest challenges at this point is that most of these systems are well designed for what I would probably term as more small to mid-sized farms, whereby the technologies probably aren't where they need to be at this point for incorporation into what I would say are larger dairy herds worldwide. However, that being said, I have seen some systems adapted to and used in, say, larger herds. And so the possibility is there, but I think we need to move forward a little bit with that technology and the development there to see more mainstream use of that within our, say, our larger dairy herds. Now, one of the things that I mentioned just prior is that not only does the process of, in this case, using, say, an automated technology to mix feed present itself, but we can also automate, say, the delivery of feed, which then is conducive to, say, doing that more often. And there becomes benefits of that as well. Not only that consistency between days is improved and we see greater precision, but we can also see greater consistency within the day in terms of the feed that's presented to cows, and then also the feeding behavior of cows. And I spoke about this actually in the last webinar that I did earlier in this year for VES-Artex, where I suggested that, yeah, when we improve the eating patterns of cows, that can have a positive impact on the rumen environment and the production efficiency of the cows consuming those diets. And so a system like an automated feeding system is going to allow for, say, improvement in eating patterns, whereby we're going to see, say, more meals per day, more consistent consumption, and improved rumen health and production. And this is just an example from a study that comes out of the US, just showing the difference between cows delivered TMR once a day and 4 times per day in terms of their milk fat content. And what you see is a clear response in those cows that were fed 4 times a day, having higher milk fat content, which we often see in studies of feed delivery, TMR delivery frequency, again, related back to consistency in intake and an improved rumen environment. And we have some new data actually that I threw into this presentation here today to basically provide a little bit more backup on that. And this is actually a study that we are currently working on getting published right now, whereby we were actually looking at robotic milking herds here in Canada. This is a sample of about 125 herds in Eastern Canada, whereby we were looking at the milk fatty acid profile of the bulk tank milk on those farms. And what we observed is that those farms feeding most often, particularly those delivering the PMR over 3 times per day, demonstrated higher de novo fatty acid proportion of their total fatty acids in their milk, which would again indicate not only potentially higher milk fat, but also a healthier, basically pointing back to a healthier rumen environment. And it should be noted that amongst these herds delivering feed more than 3 times per day, the vast majority of those were using automated systems to do that. And so again, just another example of the benefit that may be there in those circumstances. Another area related to feeding management where technology also plays a role is in the fact that we need to get feed not only delivered to cows, but also consistently pushed up and available to those cows in that scenario. And the challenge is that if we don't do that, and I've talked about this before, if we don't do that, this cow here, for example, who's looking at me taking this picture, is going to make a choice, either to stand there and waste her time, or she's going to go lie down and forego an eating opportunity, both of which are bad options for that cow. And so we need to make sure that that feed, when she's hungry, that feed is available to her so that she can then engage in that meal and then go rest and lie down. And so our task on farm is to do that. Now, again, in many circumstances, we're relying on human labor input from that perspective. Now, this is an extreme example of someone pushing up feed by hand. However, even if it's not by hand, which is again not the norm, we're often doing that with, say, human operated machinery, either a tractor or a skid steer or something like that. And the reality is that we probably can't do that as consistently, as kind of at targeted times as we'd like in all circumstances. And so with that comes inconsistency. And as a result of that, we see then effects in terms of the some of the study results that we see out there. And this is just one example again of that. This is a study published a few years ago from the Midwest of the US, where they're looking at robot herds, where they saw almost 5 kilograms, or say over 11 pounds more milk for farms that were using automated feed pushers versus manual. And you might look at that and go, wow, that's amazing. Look what the technology is doing. This precision technology is allowing us to do. My argument at the end of the day is it's not necessarily the technology itself, but the fact that the technology is doing something that us as humans maybe just cannot do as consistently, as frequently as the technology may allow for. And so in the case of this study here, it's probably not the fact that, again, these farms are using automated technology. It's probably the farms that are not using this that are just not doing a good enough job. And so at the end of the day, we don't necessarily need the technology, but it does, again, reduce that risk of human error and human inconsistency. And so that's where really the technology allows for that precision that we're looking for. And we see another example of that, more recent data. This comes from a study we did here in Canada, again, with a large sample of farms, almost 200 robot farms, where the vast majority, nearly 70%, were actually using robotic feed pushing on those farms. And the mean feed push-up frequency was about 12 times per day, so every 2 hours approximately on average. And what we observed in that case was that every 5 extra feed pushes was associated with 0.35 kilos more milk. And so again, the technology, again, allowing for that high frequency, and even within that, a greater frequency, having positive impacts there. And so definitely there is opportunity from that perspective to use that technology and allow for that precision to take place. Now, one other comment when it comes to feed availability is that it not only needs to be obviously pushed up when it's there, but it needs to be available, it needs to be there. And we still have too many scenarios where we have empty bunks, or in some cases, what I would call functionally empty bunks, where it's either just scraps left over in front of the cows, or even there's just poor distribution of feed in that feed bunk. And the reality is that when we have that, we end up changing the behavior of the cows, we change their eating patterns, and that has negative consequences on them. This is a good example of that. This is a study done from Dr. Rick Grant at the Miner Institute a number of years ago, where they mimicked a functionally empty bunk in the overnight hours from 1 a.m. to 6 a.m. And what they demonstrated, particularly with some level of overcrowding at the feed bunk or overstocking, they saw more acidosis and reduced fiber digestibility in those cows, because the cows in those circumstances changed their eating pattern. And as a result of that, they have larger meals, they slug feed the next time they're fed. And as a result of that, we see that change in rumen dynamic. And so our challenge is to make sure that that feed bunk is always full, and that we're not ending up with periods of the day when we don't have enough feed there. And again, we can do a good job of this manually if we have very good people who are reading bunks and making sure that we're really on top of our feeding management. However, in not all circumstances, we do a good job with that. And I think that's, again, another opportunity that we have within the industry to think about, is to think about what precision technologies may be available to us to do a better job in terms of, say, monitoring feeding management, and then making management decisions based on that monitoring that we may and can do in those circumstances. And again, doing this visually, manually can be difficult, but there are technologies that are helping us do that. And just as an example of that, and there are lots of kind of examples coming on board currently in this realm. There's a system that's been developed, and this is one example from Canthus, and this is their system whereby they're able to, say, for example, use a computer vision type system with cameras and artificial intelligence to basically track and monitor feed availability in the feed bunk. And this is just a couple screenshots from their program, whereby you can see on the left side here, this is a bunk that's getting empty, and you can see based on the coloration, the system is actually able to identify the amount and distribution of the feed that's available in the feed bunk to those cows. And then post feed drop, in this case, you can see the increased feed and feed availability that is available to those cows. And so with a system like that, they're able to then track, for example, when certain management events occur during the day. And so just again, screenshots from their program showing that they can track, say, when feed's being delivered, when feed's being pushed up, and then also across various pens, say within a herd. And again, this is really small and it's hard to read probably on the screen, but what it's showing is average time with low feed available to those pens across the day. And so for the most part, you see good feed availability, but there are certain parts of the day and certain pens that are experiencing low feed availability. And again, that can be put together in a nice report and can be looked at. And what all this information then can be used is to make and inform management decisions at that herd level. And I think we're going to see a lot more of that moving forward, particularly these computer vision type systems that not only can do these kind of things, but also help with individual cow behavior monitoring, looking for not only say, assist us in health management and those kind of things, but also in identifying other health-related things like lameness and other situations in cows. And we see some opportunity there with systems like this. There's a catalyzed system that's out there, as well as various other ones that are currently being developed with AI technology to be able to do these things. And these technologies are really allowing us that kind of precision approach in our management of our cows. So that's at a herd level, and I thought it'd be good to kind of split today's presentation talking about that, because again, the vast majority of the dairy industry is still and focused on milking cows in parlors, milking cows in groups, in larger groups, and so a lot of these things have to be done at a herd level. However, there's also quite a bit of interest in our ability to increase precision at a cow level. And again, for good reason. If we're able to do a better job at a cow level, we're potentially able to improve our overall efficiency, not only our nutrient efficiency and use of those within the individual animal, but also from an excretion and emission standpoint as well, as we can be or do a lot better job from that perspective as well. Now, our challenge is, again, similar actually to at a herd level, meeting the individual needs of cows accurately, and then also maintaining that precision kind of day to day in those feeding approaches. Now, you might ask, okay, where are our opportunities then? Do we have opportunities currently in the dairy industry? And probably our biggest ones that we have currently would be through the use of automated or robotic milking. We're seeing a fair amount of adoption within the industry. Just looked at the numbers from Canada the other day. We're currently sitting at about 15% of our herds that are on milk recording using robotic technology, including those that are with. We're probably pushing over 20% of our industry currently now, and probably 25% of our cows being milked with robots here in Canada. We know the numbers in Europe have been strong for a long time, and we're seeing that number increase in the US day to day as well. Now, what robotic milking does is not only obviously allow us to manage milking at that individual cow level, but also manage feeding at that individual level, given that cows will receive a certain proportion of their diet within the robotic milking unit. Now, a large portion of that, or reason why we do that, is not only to attract the cow to the robot, but also we're able to then use that amount of feed, which can be in certain circumstances, anywhere from 15, say up to 25% of their total diet. We can meet some of their nutrient requirements through that feed that we're, say, providing at the robot to those animals. The question for us becomes is, can we accurately do that? And this is where, yeah, there are some challenges, and I actually like to use this example of some data that we collected at our research farm to highlight what some of those challenges might be. And this is actually a graph of about 1.5 years worth of data that comes from our robotic milking unit at our research farm at the University of Guelph. And what you have here is each of these dots represents a cow day worth of data, whereby we have plotted on the x-axis here the days in milk of the cow, and then on the y here we have the amount of feed that was offered to those cows or delivered to those cows in the robot on that daily basis. And what you see here is that it roughly kind of looks a little bit like a lactation curve. And so you could say, okay, yeah, there is some opportunity there to shape that, say, that feed amount to the nutritional requirements of the cows. But at the same time, you see tons of variation there, right? And so within a given day in milk, we see anywhere from, in this case here, 0 up to 7 to 8 kilograms of feed being offered to individual cows. And so again, the optimist among us might say, well, that's great, because then we're tailoring that amount of feed to those individual cows. The pessimist, and that's the realist in me in this case, is saying, well, the challenge I know is that actually in our herd here, up to 120 days in milk, those cows were supposed to be getting at least close to 5 kilograms of concentrate in the robot per day. And so what that tells me is that we've got a problem here that whereby there's a certain proportion, a large proportion of cows that were not getting the nutrients that they were supposed to be getting through the robot. And so that tells me then that we have a problem. We not only have an accuracy problem, but we also have potentially a precision problem from feeding those cows individually. And so that becomes a challenge for us, is trying to figure out what might be causing some of that variation. And I'll come back to that in a few moments. One of the specific areas that we're really interested in is actually this early lactation period right after calving, whereby we know that, again, in any circumstance, cows' dry matter intake lags behind really their nutrient demands. And we've seen that exacerbated in robotic milking systems, whereby we've actually observed in some other studies some higher levels of negative energy balance and ketosis in our robotic milking herds. And what we noticed in a study that we did a few years ago, whereby we were looking at a large sample of cows, nearly 600 cows on a cohort of robotic milking farms, is that those cows that we tested for and diagnosed with subclinical ketosis, as shown here in the red line, what we saw when we looked at their milk production as a function of how much supplement they were being provided in their robotic milking system, those cows were producing more milk per kilogram of supplement provided in the robot, particularly in that first week of lactation. Now, again, some of you might look at that and go, oh, that's efficiency, but really in the case of these cows, it's coming at the expense of those cows then burning off more fat and actually going into a greater state of negative energy balance. And what this indicated to us is that we're probably in a lot of circumstances not getting enough nutrients into those cows, potentially those higher production cows, as they should be in that first week or two or even 3 weeks of lactation. And so our challenge is thinking, okay, how do we do that? How do we get more nutrients into those cows in early lactation? And specifically, and that's one of our concerns has been from a nutrition standpoint, is do so without the risk of things like acidosis in those cows at that time period where we know they're at highest risk of that, say in that first postpartum period. And so we've been looking at alternative sources of energy, trying to precision feed those within the robot to, say, increase their energy balance and get those cows through that postpartum period. And just one example of that is, this is a study we published last year where we're looking at supplementing those cows in early lactation with a molasses-based liquid feed. And again, it proved successful to some degree, whereby we did see a reduction in the number of cows that had repeat diagnoses of subclinical ketosis in early lactation. However, one of the challenges that we observed in that study was that those cows still had a high incidence overall of positive subclinical ketosis tests. And so suggesting that we still had an energy deficit overall being observed in that study population. And there's probably more things that we need to look at there. And we're following up that with current research right now to try to understand why that might be the case and what we can do to alleviate some of that. One of the other things that we're focusing in on our program right now is whether or not we can also then maintain greater precision in these individualized feeding approaches. And if you think back to that graph I showed a few minutes ago, one of the things that we saw was that huge variation, even within days in milk, in terms of how much cows were getting in the robot, even though according to the program, they're all supposed to be getting the same amount of feed. And so we've been looking at what factors might be contributing to that. And a big part of that is the fact that milking frequency of those cows may have an influence there, whereby cows are just maybe not milking to the level that we require them to. And so obviously there's housing and management and nutrition things related to that. But then the other thing that we notice is that we see a lot of day-to-day variability in terms are getting in the robot. And that day-to-day variation, as going back to even the TMR feeding, represents a problem, because if we're not consistent, then obviously that might have that trickle-down effect in terms of the production of those animals. And one of the things that we've noticed is that when we try to, say, feed cows more on an individual basis, we see more of that day-to-day variability. And this is, again, an example of that. This is a study that we published a couple of years ago, one of my graduate students, Anna Schrenke, and what she demonstrated was that when we increased the amount of feed that we provided to cows in the robot, and that's the treatment here, the LPMR. So it was a lower energy dense PMR with more feed in the robot versus a higher energy dense PMR and less feed in the robot. What Anna observed was that with more feed in the robot, we saw more variability day to day in their robot concentrate intake. And so that's represented here in the basic standard deviation across days in terms of their robot feed intake. And even though we didn't see any statistical change in their PMR variability or total dry matter intake variability, what we know is that because of this variability, then even though the amount of feed that those cows were consuming day in, day out didn't necessarily change, the composition of that feed would change day to day. And so again, going back to my TMR example at a herd level, that inconsistency in terms of what cows are consuming day in and day out could potentially have a negative impact then on the productive capability of those cows. And so a question that we have, and we're currently working through, and again, this is one of the challenges that we have in this approach, is thinking about what might be contributing to some of that variability. And going back to what I mentioned before, we have variability in milking frequency that might be related to housing, that might be related to management. But then there's also probably cow level variation that is contributing to this. And this is an area that's kind of new, but I thought I'd present just to finish this presentation off today, because we see some huge variability between cows in terms of how they perform in these systems. And it might sound a little bit funny to you, but that between cow variation or individualness in their behavior is really a reflection of the personality of the cows. And however you want to describe that, it's really how that individualness contributes to the behavior kind of profile of those animals. And so what we're currently doing is looking at how that cow personality, as assessed through basically what we call personality tests, influences their ability to, say, milk and be fed through robotic milking systems. And the way that we do this is actually subject cows to a novel arena object and person test, where we put them in a novel arena, watch what they do from a behavior standpoint. We give them a novel object, like you see in the video here, hopefully. Watch what the cow does. Does she interact with the bin? Is she afraid of it? Does she move away from it? And then we put a novel person into the pen, as you see on the right here. And same thing, look at what the cow does in that circumstance and score the behavior of the cow in relation to that situation. And from that, we're able to then characterize the behavior of those cows and actually assign what we'd classify as kind of personality categories to those animals, either active, social, alert, curious, vocal, or fearful. And then use those behavioral profiles to understand whether or not that's influencing our nutritional strategies for those animals as well. And this is where it gets really interesting, in that this is some really new results that we're working on. Is that one of the things that we've demonstrated is that those cows, for example, who are more alert, curious, less active, and more fearful are probably less likely to be able to achieve a higher level of feed in the robot versus cows, say, on a low level of allocation. So those cows with a low level of feed allocation doesn't really matter. However, those cows with a high level of feed allocation to the robot don't necessarily quite get to that level of feed consumption that we would hope based on their individual behavioral profile. And so that can then contribute to some of that variability. this is another result. In this case, we took a group of cows and either again fed them a higher level of feed in the robot, 6 kilograms per day, or a lower level of feed in the robot, 2 kilograms per day, and then compared their milk production response on those two treatments to the level of boldness. So basically on a scale, whether or not cows were, you could think of cows on the low end being shy versus cows on the high end being very bold or almost dominant, you could say. And what you see is that actually for the cows on the high level of concentrate, it doesn't really matter. They all achieve a very similar level of production. But for those cows on the low concentrate allocation, those cows that are shy actually have a lower level of production. And so again, you might look at this and think, okay, this is great and all, very interesting, but what's the kind of the practical value of this? I think long-term, and again, this is just baby steps at this point, the practical kind of application is thinking about whether or not we can identify, say, maybe which behavioral traits are very important in these cows. And if we can do that from, in this case, from a robotic milking and nutrition standpoint, can we then start to select cows and use our genetic selection to actually hone in on those behavioral traits? And at the end of the day, end up with cows that are going to be more adaptable and better situated for these types of individualized management, milking, feeding type approaches. So that gets me to the end of my presentation. I did want to throw in this one last scenario, so to speak, and that's whether or not this kind of idea of precision feeding can be applied or brought to other scenarios. And I like to bring this example up. This is from Dr. Alex Back from Spain. And this is just a system that he's worked on and developed and incorporated into a commercial farm, whereby they developed an on-demand feeding approach system for individual cows in a rotary milking parlor. And so it doesn't necessarily have to be done in a robotic milking scenario. We can also see that in this scenario, whereby cows in real time come onto a rotary parlor, whereby we have body weight that was taken on entry, we have their production level from previous milkings, we have their stage of lactation, their age, size, growth requirements, all those kind of things. And in this case, Alex developed a system whereby it can, within seconds, deliver an individualized commodity-based concentrate for those animals based on the individual animal's needs. And so again, a unique situation, but I think we're going to see a lot more of this thought and development as we move forward in the industry, as we try to identify more opportunities for this greater precision at a cow level as well. So with that, take-home messages, we are seeing opportunities in precision feeding in the dairy industry. A lot of that's being driven through automation adoption and development of automation. And when we see that at a herd level, we see opportunities, and as I described, in terms of diet preparation, delivery, and access, and all of those things can be done with technology to improve both the accuracy and precision of our diets. And again, at the individual cow level, we can also accomplish some of that as well. And specifically, currently, most of that is being done in robotic milking, but there are other opportunities kind of coming on that front as well. And again, more research still needs to be done on a lot of circumstances, but we do have a lot of opportunities there. So with that, I would like to thank various funders of much of the research that I've presented here and today, for which this wouldn't have been possible otherwise. And I'd like to thank you very much as audience for your participation, and look forward to any questions that you might have.
Thank you very much. This was a great presentation. We have a couple of questions that have come in, but I'd like to start with one that says, does incorporating TMR feeding technology guarantee more intake and greater milk?
So just repeating it, Karen, again. So you said incorporating robotic feeding technology, does it guarantee?
No, sorry, incorporating TMR feeding technology guarantee more intake.
Yeah, so good question. So yeah, does incorporating TMR feeding technology guarantee more milk and intake? And I guess the short answer is no. However, what it does potentially do is guarantee that consistency. Now, again, if consistency is an issue, definitely we can have limitations in terms of dry matter intake and overall production of those animals. What it can also do is promote, say, a improved eating pattern, as I described before as well. And so with that, we might see improved eating behavior, improved rumen environments, which then translate into potentially better fiber digestibility, which can, again, relate back to intake. So it can actually drive intake, or probably more commonly, what we see is actually just improvement in things like milk components, whereby we're seeing the nutrients actually being used much more efficiently in those animals.
Thank you. What happens to de novo FA over 3 times feeding? And is there a continued increase at 4, 5, 6, and 10 times feeding?
Yeah, that's a good question. Yeah, and I presented the data that way because based on that study, that was a study that I described. It was 125 farms that we were looking at, whereby we saw probably close to about a third of the farms feeding once a day, a third twice, and a third feeding 3 times or more. We didn't have enough herd variability to break that down further. So again, over the 3x feeding per day, we didn't necessarily have enough variation in that to look at that. And so I can't say with confidence that we would see a difference in say de novo fatty acid proportion in those herds feeding say 8, 9, 10 times versus 3 or 4 times per day. That being said, the majority, and I think I mentioned this in my presentation as well, the majority of those herds that were feeding more 3 times or more per day were actually using automated systems, and those using automated systems were in generally feeding at least 6 times per day.
How did consistency of robot visits correlate to the consistency of LPMR study?
Yeah, that's also a good question. And there's definitely an association there whereby the amount of feed being provided in the robot does correlate back to the milking frequency and the milking interval of those cows in the robot. And so the two do go hand in hand, whereby if we see more consistency in milking visits, we should see more consistency in the feed that those animals are consuming or receiving, sorry, at least in the robot. We don't necessarily know they're always consuming it there. The challenge is, and that's partly why we're doing this other work, is that we're trying to identify what might be then affecting that, say, robot visit consistency as well. Because again, there's a lot of things that are going to influence that, including just the behavior profile of those individual cows. And so if we can do a better job trying to kind of minimize that, or at least identify what factors contribute to that variation, we're better able to maybe control for some of that moving forward.
And how often was the feed pushed in a study where you were evaluating the effects of the de novo fatty acid production?
Yeah, good question. So actually, in that study, basically the same data, that study where I showed the de novo fatty acid production from the 125 herds, actually those herds are a subset of those in the larger study on robots that I described, where we had 197 farms, and we looked at feed push-up frequency within those. And so the interesting thing is that the feed push-up frequency across those herds varied dramatically. And there was not necessarily a direct correlation between, say, their feed delivery frequency and their push-up frequency, mostly because in that scenario, the vast majority of those herds were using automated feed pushers and were actually pushing up feed like I said before, about 12 times per day on average. To answer the second part of the question, because I think it's in the chat there,
Yes.
yeah, what effects would you expect with once or twice a day feed delivery and continuous push-up? Again, you might get a response there. However, and it goes to the idea of that feed push-up, and this is my take on this, is that the reason we push up feed is to really make sure that feed's available to cows when they're hungry and they go to the feed bunk. It shouldn't be what stimulates cows to eat at the feed bunk. The internal drive of the cow, as dictated by her hunger level, which is going to be largely dictated by her energy demands, as well as the feed she's consumed, so the digestibility of that. So basically better forage digestibility, quicker digestion, a faster return to eating, that should drive the cow to the feed bunk, not the pushing up of the feed. That push up just ensures that that feed is there. We do know, however, from other research that feed delivery and basically fresh feed, it has a different effect than, say, feed push-up does. And so that does drive meals a little bit more as well. And so there's a little bit of a difference in effect there. And so again, if you're only feeding once a day, then yeah, definitely making sure feed's pushed up as often as possible and keeping that feed turned over and mixed up is going to have probably a greater benefit than on a herd that's feeding more often. That being said, the effects of those should likely be different.
All right, and our next question is, how often should an automatic feeding system feed the cows? Which I think you just touched on.
Yeah, and again, there's no exact number out there. I've seen systems where people are delivering feed with automated systems 4 or 5 times a day, 6 times a day, 8 times a day. Not sure if there's anything necessarily kind of over that. We don't have science to say what's optimal. What I would suggest is that we need to, in any circumstance, look at the behavior of the cows. If we see cows running to the bunk at every feed delivery, we're probably actually not, with an automated system, we're probably not doing it enough, because what we want is a scenario where that feed is continually fresh. Cows decide when they want to go to the feed bunk and do so. And so part of that also means we're not running out of feed in between deliveries as well. And that's where I've seen actually even those types of systems fail, where we're providing a lot of little meals to cows per day, but then we're also running out of feed between deliveries. And so that's another just aspect of management that has to be watched, and that we don't have that happen either.
So why did we abandon individual cow grain feeding in favor of TMR feeding?
Yeah, I think some of that was technology based, right? The old system, some of the old systems was, yeah, individualized feeding in the barn with grain feeders, and those were problematic. There was and still is actually grain feeders available in milking parlors and in parallel parlors, in rotary parlors that are out there. I still see some of that. I'm not sure it always failed because it wasn't a good concept, so to speak, but rather some of the technology and what we were trying to do with that feed in those situations. The example I gave at the very end there, whereby we can maybe deliver a personalized type feed for an individual animal, might be where we need to go in the future, rather than kind of blanket feed all cows. And that's generally what we were kind of trying to do in the past. We would vary the amount, but not necessarily the composition of that feed that we're providing. And so I even see that for robotic milking as well, whereby we're feeding individually. I'd like to see actually potentially to increase the precision, what we do in the future, have a greater ability to adapt what we're feeding to the individual cow, not just the amount of feed.
Thank you. And to prevent some subclinical ketosis in the first 21 days in milk, could you keep the cows in separate pens behind the robot and feed an extra ingredient or two in the PMR after the main herd has held or helped control ketosis?
Yeah, no, that's a good question. There's lots of thoughts and potentially opportunities, I think, when it comes to these things. Often we're limited, I guess, just based on our barn designs, right? In terms of how we've, say, built our robot pens, and we didn't necessarily always think about some of those opportunities. There are some systems out there like that where we have either special needs pens, training pens, or fresh cow pens. And I've seen some great examples of that where they do that, where they have cows actually in a pen with a sort gate behind the robot or beside the robot, and are able to feed them differently there and then move them on. I think that's a great opportunity. But again, we have to kind of have forethought in terms of our design. That's the challenge sometimes, is that if we've adapted facilities or even in new facilities and we haven't thought of those things, it becomes hard to do later on. Moving forward, though, I see some more opportunity. Large farms that are obviously moving to robotics, they are doing that now with fresh robot pens, so to speak. But even in our smaller farms, there is that opportunity to, say, manage those animals separately for a short window after calving.
All right, and our last question is, what do you think about additional feed boxes in conventional milking systems?
Yeah, so I guess this kind of goes back to the other question of why we moved away from this in the industry, right? And so again, our approach in TMR feeding improved over the years, and we kind of moved away from this idea of having individualized kind of feeders for cows, or feeding stations, for example, for cows in our barns. I'm not sure where this is going to go in the future. I've seen some current farms that do this now, both actually in dry cow programs and in milking cow programs, and it can work. However, just from a kind of a guaranteeing feed in front of animals and the animals visit those and those kind of things, it's probably the least, or it gives us the least guarantee versus, say, providing it within a milking system, like at a robot or say in a parlor type system. And so my guess would be that this isn't, if we're going to move to any kind of individualized feeding, it probably wouldn't be in that format. It would be a milking related type format.
Well, thank you very much. This has been really well received, and we had a lot of great questions come in. So thanks everybody for participating. And Dr. DeVries, we'd just like to say thank you for coming out.
Great. Well, thank you.
And I hope everybody has a great weekend. Bye.